Almer B is a large gas giant and orbits the furthest of the main two bodies around the parent star. Analogous to Jupiter, it is slightly larger in size and mass, and thus exerts a great amount of influence over the star system it inhabits, both it and its star orbiting a barycenter that lies far outside the surface of the star itself. Initial observations of the Almer system predicted Almer B to be a brown dwarf star. However, exploration missions revealed this to be incorrect, the prediction possibly being the result of a smudge on a monitor causing the planet to appear bigger and brighter than it actually is. We fired the researchers who predicted that. While Almer B is a fairly large gas giant, its mass is not sufficient to achieve any kind of thermonuclear fusion, meaning it is definitely a planet and not anything else. Almer B's atmosphere is primarily composed of hydrogen and helium, as well as trace amounts of various elements such as hydrocarbons and ammonia crystals, which give the planet its yellowy-brown colour. The bands that form on its surface are caused by heat emanating from the planet's core, causing warm gas to rise to the surface before cooling and falling back into the planet. The warmer rising gases comprise the lighter bands, while the cooler shrinking gases form the darker bands. Like most gas giants, Almer B likely has a rocky inner core that nobody has actually been to yet. We sent a guy into it, and he died quite quickly, so we stopped doing that. Being such a large planet, Almer B has many moons. As our scientists are fairly lazy, we don't know exactly how many moons orbit the planet. However, the general consensus is that there are roughly 120 of them. Most of these moons are fairly small and insignificant moons. However, there are three larger inner moons that I'll be discussing today. Those are Almer B 1, 2 and 3. Before I launch into this, I'm aware that a better and more interesting naming system needs to be devised, and if you don't think it's that bad, then you will very soon. So the three moons orbit in a Laplace-like manner, with a roughly 1-2-4 resonance. This means that there are two conjunctions of Almer B1 and Almer B2, and three conjunctions of Almer B1 and Almer B3 for every one conjunction of Almer B2 and Almer B3. I'm aware that was confusing and involved a lot of numbers, so it's basically the same way that Io, Europa and Ganymede orbit around Jupiter for simplicity's sake. Almer B1, the closest and smallest of the three moons, is an ice-covered world with a subglacial ocean, which is made possible primarily due to tidal heating. It is unknown if Almer B1's subglacial ocean spans the entire moon, or if it is limited to large pockets around its equatorial regions. Analysis of the plumes of water erupting from the moon's surface unfortunately have not yet revealed any evidence of organic processes occurring in the subglacial oceans. However, research is ongoing. Almer B2 has a dense atmosphere primarily composed of nitrogen, as well as a heavy helping of methane. This methane manifests on the surface in pockets of hydrocarbon seas that pool in various impact craters scattered across the planet's surface. Geological observations of Almer B2 suggest that while the moon may have seen tectonic activity in the past, this has since died down. Almer B2 lies on the periphery of Almer B's magnetosphere and dips out of it for brief sections of its orbit. Because of this, its thick atmosphere is slowly being stripped away. Almer B3 is a large and rocky moon, similar in composition to our own moon, however significantly larger in size, even larger than the Jovian moon of Ganymede. Almer B3 produces a faint magnetic field which allows it to cling onto a thin oxygen atmosphere. Features on the moon's surface suggest tectonic activity occurring, and speculation of subsurface oceans are fueling interest in future missions to this moon. And that concludes the episode of this world building project. Hopefully you enjoyed it and it wasn't too ridiculous and scientifically inaccurate. Anyway, next time we'll be looking at Almer A, which has life on it, so that should be fun. So yeah, see you all then.